Yeah, so let's talk about decision trees. Ah, good. And I see Jonathan saying use Chat GPT to get information about concepts. Yes, very good. Um, good. And he's got an analogy to help him understand the polynomial kernel. Well, that's good. Yes. And by the way, that's a very good idea. Use ChatGPT in class to explain anything you don't see. So, decision trees. This is wonderful and very simple. And again, like support vector machines, it is so simple you might imagine that it wouldn't work. But here's how it goes. We're going to use the PEDAL database that I talked about in the lecture, a famous machine learning case where people measured the 3 distances on some flowers and then separate them into various categories. And so here's the first 5 X and Y, which is petal length and petal width. And then here are the counts. And there are 3 different species of iris, and we have 50 samples of each of them. So we're trying to do a classification task where we're just going to sort them into subcategories. And we're doing it here with a decision tree, which is very easy to understand. In fact, unlike the previous machine learning, this decision tree is easy to understand in coding terms. It's just a series of if statements. So here's the decision tree. This is the if statement. Is the petal length less than or equal to 2.45? If it's true, you go here. If it's false, you go here. Then you see if the petal width is less than 1.75. If it's true, you go here. If it's false, you go here. And that's it. That is the decision tree, 2 if statements. And what the machine learning model has done is just optimize these if statements, what boundary to take. And it has measured it by this thing called Gini impurity. And the Gini impurity is a measure of how mixed the contents of this are. So a highly impure thing like 0.6 is because this contains 50 instances from type species 1, 50 from species 2, and 50 from species 3. And it chose a decision boundary that would maximize the improvement in purity. And as you can see, this caused this one to be perfectly pure. 50 examples of species 1 and none of the others, so the Gini impurity is now 0. So this is the end of the job. We have now completely classified those. And over here, the 2 remaining sets are here, so this Gini impurity has fallen from 0.6 to 0.5, but it's still pretty impure. And so now we separate it with this, and now we have almost perfect purity here, 49 in this class and 5 in that class. And here, 1 in that class and 45 in that class. You see the Gini impurity has gotten smaller. And it stops at this point, even though you could have more layers going further. But I think we set the total depth of the tree somewhere up here in the parameters. Might have just let it quit when it figured it's not worth it. All right, you get the 5 nodes in depth 2. And that's the Gini impurity. And now we can draw a decision boundary and a graph to see how these decisions look, displaying all the information about the data here. And as opposed to that polynomial fitting that would put curves, you can see here it just uses lines. This is the first if statement, splitting it into 2 classes, and then the next if statement splits these into classes. And as you can see, it's not perfect. There's some green dots down here and some blue dots up there, but it's pretty good. And that's a decision tree. So you can change the depth. That's what I thought. The max depth should have been defined in the second block of code up here. There it is, max depth equals 2. That's why it only got to make 2 if statements. And you could increase that and let it make more if statements, and then it would be a better fit in more categories. All right, so now we're going to use the same thing to fit a curve. So I'll create a curve and noise here. All right, so now I have a curve, and this is one we've used before, a curve that is x times cosine x, so it's a wavy curve that does not have a simple pattern. And now we're going to fit it with a decision tree. And here's this if statement. If it's true, go here. If it's false, go there. If it's true, go here. If it's false, go there. Now, you don't have Gini impurity now because this is a fitting task, not a classification task. Instead, you have a measure of the squared error, and you're trying to make the error go down. So the original, just having a single value, horizontal value, gave an error of 0.2. Now the error goes down to 0.1 and 0.03 here, and the error goes down here. And you just let the tree go until it decides it cannot improve things. And you can see the predictions. And so, as you can see, it's pretty miserable. It only very approximately follows the curve. It's just a series of horizontal lines. You need a deeper tree with more parameters to get a more fine stepwise fit. And I think that's what we got coming next. Yeah, if you change the depth to 6, you'll get a much better fit, of course. And so this is another way to do it with just a series of if statements. And you can give it unlimited depth, and then it will overfit and severely hit every single point with very, very many if statements. So it's, again, another very simple model, but it's often good enough for a lot of purposes. I'm going to stop that one.